This is lesson 2.1 and 2.2 for this unit. We're using the tangent ratio to calculate angles and lengths. There are a few words that you're really going to have to know when we're talking about tangent ratios and cosine and sine, which we'll talk about in a different lesson. One of them is adjacent and the other is opposite. Now, every time you see these two words, they're talking about a single angle. In this diagram, they're talking about angle A right here. Okay, so angle A, the side adjacent to or right beside angle A, is side length between B and A right here. Now, there's another side to a triangle, and that is our hypotenuse. Okay, our hypotenuse is always the longest side of the triangle, and it's always exactly across from the 90-degree angle on a triangle. So I'm just going to get rid of that because that's not actually what we're talking about right now. I'm going to leave hypotenuse there for a minute. Opposite is the side that is across from or the furthest away from whatever angle it is that you're talking about. So we always have to know what adjacent and opposite are. Opposite is the furthest from the angle, in this case side CB, and adjacent is the closest to, but not the hypotenuse, okay? So let's take a look at the tangent ratio. If angle A is an acute angle, which means it is less than, let me just write that a little bit clearer, less than 90 degrees. Okay, acute is less than 90 degrees. In a right triangle, when it says right triangle, it means it has to have this 90 degrees in the corner right here. Okay, so if that's the case, the tangent of angle A is the ratio of the length of the side opposite angle A, in our case CB, to the length of the side adjacent to angle A, which in our case is BA as a side. So let's take a look at the sentence below. The value of the tangent ratio is usually expressed as a decimal that compares the lengths of the sides of a triangle. For example, on our diagram here, if tangent of A is 1.5, so if we calculated that ratio, tangent of A equals the length opposite, I'm not going to write the whole word down, maybe I will, opposite over the length adjacent. This is 1.5 right now. Then any similar triangle, any triangle that has this same ratio and angle A, the length of the side opposite to angle A is always going to be 1.5 times the length of the side adjacent to A. So let's take a look at our triangle here. We have angle A, we have our opposite side, we have our adjacent side, right? Actually, this is hypotenuse. This is our hypotenuse. I've made a mistake here. Let's erase that. Our adjacent side in this case is the one that is not that is not the hypotenuse. So our opposite side is 1.5 times the length of the adjacent side. That's what this tangent of A tells us. You can use your scientific calculator, and remember, a scientific calculator is anything that has things like square root or tan for tangent or x squared. Those types of things are involved in a scientific calculator. You use your scientific calculator to determine the unknown angle, so any angle that you don't already know. The button you will need to use is tan to the -1, which is the same as tan inverse. Inverse just means the opposite of something. So instead of having tan, we have 1 over tan. That's the tan inverse. Okay? So for our example here, for A, we have tan of x. So we find our angle x here, and we need to find the tangent of x. Remember that tangent is always opposite over adjacent. Where opposite is directly across from the angle, so in this case it's x, and adjacent is the side beside the angle, but not our hypotenuse. Okay? So in our case, the opposite is 6 and the adjacent is 12. So let's plug those numbers in here. 6 over 12. We can reduce that, and that easily becomes 1 over 2. Now what that really means is the length of the opposite side, 6, is 1/2 of the adjacent side. So 6 is half of 12, and that works. So that's perfect. Let's take a look at tan of z. So this time we're using z as our angle. In that case, it's still opposite over adjacent. But this time, opposite is our 12, and adjacent is our 6. This reduces to 2. And it means that the opposite side, 12, is twice the length, or 2 times the length of the adjacent side. All right, we can also use tangent to find what an angle is. So whenever you see this symbol right here, with the little less than sign and an angle, you're trying to define what is the angle. That's what it's asking you, okay? So we can then use our tan inverse, which is what we were talking about before, tan to the -1, and you will actually see this on your calculator, so you will need to use that button. If you don't have a scientific calculator that can do this, you need to go out and purchase one, okay? So you need to buy one. You need to have some kind of calculator, some type of scientific calculator that can do this. So the tan is always, for x, opposite over adjacent. So this is the same. I'm going to write 6 over 12, opposite over adjacent. All right? You will need to remember to be in the degree mode in your calculator. Okay? That's just a little reminder. Okay? So when I plug the tan inverse of 6 over 12 into my calculator, I get 26.565 degrees. Okay? If you are plugging this into your calculator, what I'd like you to do is just pause now, plug that in, and see if you get this angle. If you do, great, you're on the right track. If you don't, let me know and we'll try and work on this together. But every time you're talking about an angle, you usually want to round to the nearest whole degree. So I'm going to round this to 27 degrees, put a box around that, and call that my final answer. Okay, moving on to our example D. I'm going to keep the triangle so that we can still see it. Z, the angle of Z. So we need to find the angle, so we're going to use tan inverse. Opposite over adjacent for Z, opposite is 12. Adjacent is 6. So when I plug this into my calculator, I get 63 degrees. Now I could also, from our triangle, decide that I know that one of my angles is 90 degrees, because I have this little square in our diagram. One is 90 degrees. I already know that the other angle is about 27 degrees. That's for angle X. And I know that an entire triangle has to be a maximum of 180 degrees. So if I take 180, which is my total amount of degrees in a triangle, I minus the 90, I minus my 27, I also get 63 degrees. Let's take a look at example number 2. Oh. A support cable is anchored to the ground 5 meters from the base of a telephone pole. The cable is 19 meters long. It is attached near the top of the pole. What angle to the nearest degree does the cable make with the ground? Alright, so there are a lot of words in here you might not understand. Support cable, alright, telephone pole. So we're going to draw a picture as the very first thing we're doing. So this is my telephone pole, and hopefully you will recognize it from my potentially horrible drawing. Okay, this is all shaded in. You might have seen these. These are generally made out of wood. They carry cables that telephone wires are on. It's pretty fancy. Okay, so here's my telephone pole. A support cable is something that usually runs from the very top of something down to the ground. So that's my support cable. I know that where the telephone pole and the ground meet is a 90-degree angle. I have some unknown angle here, and when you don't know an angle, you usually use this fancy zero with a line in it called theta. Theta. Okay, theta. I know from the question that the cable is anchored to the ground 5 meters from the base of the telephone pole. So this is 5 meters. I know the cable is 19 meters long, so the hypotenuse of my triangle is 19 meters. And it says, what angle to the nearest degree does the cable make with the ground? So we're solving for theta. All right? It's important for us to know at this point that we do not know the side adjacent to theta. Okay? So we must use Pythagoras. Okay? Because for tangent we need opposite and adjacent, we don't actually have the opposite side. We do not know the side opposite to theta. Okay? So we know that a squared plus b squared equals c squared. We know that a squared is what we're trying to solve. This is our opposite. We know b is 5, so 5 squared equals 19 squared, because we already know the hypotenuse. So a squared, we're just going to work this all out. 25 equals 361, which is 19 squared. So a squared equals 336. So just a equals the square root of 336. Okay. We know that tan of theta is the opposite. I'm just going to write this short over adjacent. Okay. In order to get rid of the tan on this side, I'm going to multiply by the inverse of tan, so the opposite of tan. This is the same as dividing by tan. Okay, so when I work this out, it ends up being theta equals tangent inverse of opposite over adjacent. Okay, we plug in the numbers. My opposite for this, I know, is now square root of 336. So I have the tan inverse of 336 over adjacent, which is 5. If I plug that into my calculator, I end up with 75 degrees. Theta is 75 degrees. That is my final answer.